In this video, let's talk about the stack. So firstly, let's understand the definition of it. So simply we can say like this: a stack is a linear non-primitive data structure. So why it is called as a linear? Because the operations which we performed will be in a linear fashion, unlike our trees or graphs. Whereas it is called as a non-primitive because uh, the data structure or data type is not predefined by the machine, unlike the int data type or float data type like that. So it is a linear non-primitive data structure which follows the principle of LIFO, which follows LIFO principle. So what is LIFO? It is known as a last in first out principle. So what does it mean by last out? The last element which was inserted into stack is the first element. So the last element which was inserted to the stack will be the first element which can be accessed. So it is the first element which can be accessed. So how we can define as a whole this stack is, it is basically a linear non-primitive data structure which follows the last in first out principle, where the element which was inserted in the last can be accessed at the earliest. This is how we can simply define the stack data structure. And coming to the next thing, we'll also talk about one example. So simply talking about example, we can, so let's say we have arranged the books in this way on a shelf on a table. If we arranged the books in this way, like this is some chemistry book, this is some physics book, this is some mathematics book, and this is some English book. So the last book which was put on the table was English book. Now the first book which can be removed from this list or from this stack will be this English book only. Another example we can also talk in this way: the CD stand. So there will be multiple CDs placed here. So the first CD, this is the last CD which we have inserted, right? This is the last CD, and the first CD which we can remove or which we can access is the last CD which we have inserted. So this is also one example of the stack, the practical example of stack. So we have completed about that, what is the definition or introduction about the stack. And next let's understand the logical representation of stack. Now let's understand the logical representation of stack. So how it is represented, let's see. So this is the logical representation of stack. Here each of these box can be assigned to one index. Let's say this is index 0, this is index 1, this is index 2, this is index 3, and let's say this is index 4. So here the size which we took, the maximum size which we took here is 5. So if let's say we assume that the maximum limit of stack is 5, then it can store a 5 elements. And also there is one important thing which we need to understand, because the stack can store only a single data type. Example, it can be int or float or any char, but all the elements should be of same data type. So all the elements in the stack should be of same data type. So let's say we assume it is an int, then all should be integer. So the information, let's say we have written 10 here, we have written 20, 30, 40, 50. So now the stack is full. So this is how we can put the elements here. And next thing which we need to understand here is the top. The top is basically referred to the index in the stack where it represents the highest what we can say is simply to say top will be pointed to the data element in the stack where to the last element. Basically it points to last or latest data element in stack. So in the stack data structure. So this is how we can define. If let's say 1, 2, 3. So this is 20, this is 10, 20, 30, 40. There is no 50, but the maximum size which, so here the no element is filled basically. So now the top will be pointed to index 4, sorry, index 3. So the top will be pointed here. If also there is no element here, these two are empty, let's say these two are empty, then now the top will be pointed to here. So it simply points to the last or the latest data element in the stack data structure. This is one thing. And yeah, and also we need to understand about the overflow and underflow condition. Overflow condition and underflow condition. So what do you mean by overflow condition? So let's understand it with an example. So this is 0 index, first index, second index, third index, fourth index, assuming that the maximum size is 5. Maximum size of stack is 5. Hypothetically, if there are no elements, we will be pointing stack to top to -1. So whenever top is -1 means we say that there are no elements in the stack. So the stack is empty. In that case, we call it as a underflow condition. And if what is overflow condition means if there is all the elements are filled in the stack, let's say 10, 20, 30, 40, 50. So now the stack is full. Actually the stack currently is pointed to here, the fourth index. If we want to increment the stack further, means if we want to increment the stack further, it will be pointing here, which we generally call as an overflow condition. So overflow condition. So whenever the top value, so the top is pointing to more than index value. In this case, if it is pointing to more than 4, then we say it as an overflow condition. Underflow condition is when top becomes -1, or we simply say top is less than 0. So in this situation we call it as an underflow condition. This is the overflow condition. Those two things. Then so yeah, we have completed overflow condition, underflow condition, and what is the top we have understood, and what is the max also we have understood. Max means here the maximum size that a stack can store its elements. Next, coming to properties of stack. Yeah. So we already know about the one of the property of the stack is LIFO, last in first out. The last element which was inserted will be the first element which is readily available to be accessed, and it is the first element we can roll it out. This is LIFO, and it is a single access point. So what do you mean by single access point? Means here they are referring to top. So in a stack we know there will be only the top. So topmost element can only be accessed in the stack. So no other elements can be accessed. So only with so the first element that can be accessed in the stack is basically the topmost element, and no other element can be accessed. So it is single access point, and so limited access because the same reason, because we can't access any other element in the stack other than the top element. And the next thing is dynamic size. So basically we need to understand that the stack can be implemented by two ways. Stack can be implemented either by arrays or by linked list. So in a later class we will understand how we will be implementing practically the stack with arrays and linked list. So as of now we need to understand stack can be implemented through arrays and linked list. So what does array mean? It is basically a static size or static memory. So static memory is what the array concept is. So we can't extend the size of array anymore. If we have predefined it like 5, so the size will be 5 only. We can't extend any further. Whereas in linked list, it is the concept is basically the dynamic memory allocation. So we already saw in a the linked list. Basically we can add a new linked list. So how we can add? Basically we will be using the new node is equal to the, we will be using the malloc function, so which we have already seen it in the linked list class. So by using the linked list we can have a dynamic memory allocation concept, and the stack can be also having the dynamic size by using this linked list. By using the array it will be having the static size. So this is broadly about the properties of the stack. And next is, so basically if we simply categorize or differentiate between the array, linked list and stack, so array can have a random access. So how it can have a random access? Because it will be having the index, so we can access any index by using just that index number. Like we know this is, if this is the just the array, so this is 0 1 2 3 4, so we can access this element directly by using this a of 2, a 2 in the square bracket, and we can access this fifth element by using a of 4, index 4. So this is what the random access is possible in the array. Whereas in linked list the access can be in the sequential. So if we take a single linked list means, so the access, so if I want to reach this third node, so how I can access? From the head I will be reaching until the node 3 by concept of traversal. If it is double linked list it is more easy. So basically in linked list, so by using the concept of traversal we will be able to reach the desired element. So this is known as a sequential access. So sequentially we are reaching the data element which we want to reach. And now coming to the stack, it is having a limited access. So we already understood what do you mean by limited access. Limited access means simply we can access only the topmost element. So through that only we can access other element. So we can't access any element directly, unlike the array. So this is the mostly the differentiate between the concept of array, linked list and stack. And now coming to the operations. So basically it is having mostly many operations, but these are the most frequently used or popular ones to understand initially. So push means we are just the pushing element, so we'll understand it separately. So first operation is push. So push means we'll be inserting element, so we can insert element into stack. So where we can insert is basically at the top. And also the next operation is pop. So we'll be inserting elements means the how the function will be of this type, push of some data we need to give. So let's say, so example is I said push of 10, so 10 will be pushed here because as there are no elements initially, so initially the top will be pointed here. And pop means basically it is a delete element at top of stack. So push means insert element into the stack at the top of stack only it will be inserting. And pop means deleting the element at the top of stack. So here the top of stack, so if I just say pop means the at the topmost element, whatever might be the topmost element, it will be deleted. So if I use it, the pop means that again the top will be decremented. So simply we can say also this way. So while using the push, we'll be incrementing the top. After implementing the pop, we'll be decrementing the top. And the third operation is top, or we can also use the function peak. So what it returns is basically just returns the topmost element in stack. So it basically neither push nor delete. It basically neither push nor delete or pop any element. It's just for viewing only, viewing top element in stack only. So this is the main purpose of using the top function. So it just returns whatever is the top element in the particular stack is. Next, fourth is empty. This function returns true if stack is empty. So how we know stack is empty? So basically if top is equal to -1 means the stack is empty. And the fifth important operation is full. It returns true if stack is full, else return false. So how we know stack is full? If top reached the maximum size. So in this case maximum size is 5, let's say. So the top will be at 1 2 3 4. So the top will be at here. So max -1. So because we are using index, so it is maximum -1. So if top is equal to max -1, then it returns true, else it returns false. So these are the major important operations that we use in the stack frequently. And coming to the next thing, the applications. So applications, so there are many practical applications which we use with the stack. So one important thing is reversing a string. So let's say I just wrote A, B, C. I inserted A, B and C. So how I can reverse? I have added first A, then B, then C, right? How the first I can remove C, then I will be removing B, then I will be removing A. So here we have reversed a string. Like that we can also do with the list. And the second thing is recursion, or it can be also called as a function call. So you can use stack for recursion also. And the third important application is the evaluation of postfix expression. And next important application is infix to postfix or prefix conversion. So we can do it. So we can convert from infix to postfix. We can convert from infix to prefix. And the next important thing is tree traversal, like binary search tree, all those things we can use this stack concept. And the next important practical thing which we use is undo operation, undo mechanism. So undo mechanism is also the same thing. So like I have inserted A, I have inserted B, I have inserted C. So I want to undo the insertion of C. So simply I will be just removing it. So this is what the undo mechanism which we can implement with the help of the stack. So this is broadly about the stack conceptual thing. So in later classes we will discuss the practical implementation of this stack data structure.